Towards the end of 2024, members of the CCPN team published a proposal for incorporating NMR relaxation data into the NMR Exchange Format. The proposal document is available on the GitHub NEF page. We hope that many people will study this document in detail and provide feedback for improvements before it is put to the NEF Consortium for approval. The NMR Exchange Format is a community effort, and it is really important that the whole community contributes towards its definition, so as to improve it as much as possible and give it widespread support. This presentation provides an overview and introduction to the document. I will first go through the background and principles underpinning the NMR Exchange Format, briefly mention the reasons for our proposal, before going through each of the 6 parts of the proposal and wrapping up with some comments about next steps. The NMR Exchange Format was always conceived as a lightweight format, which would place a minimal burden on software developers. This means that it carries only the minimal information that is required for moving data between software packages, or in and out of the BMRB, without loss of information. It is important to get this balance right. The star syntax was chosen since this is already used widely in the structural biology community, it is humanly readable, and it is easily extendable with program-specific namespaces. Here is an example of the star syntax. Different types of data are placed in separate save frames. So here, for example, is a molecular system save frame, which specifies the sequence of a protein or peptide. Loops within a save frame function as table headings followed by a table. And here you can see an example of how it is possible to include an additional item of data using program-specific namespaces. Here the CCPN underscore prefix has been used to add an extra column to the loop table. A number of save frames have been defined for NEF. Most are fairly self-explanatory and centred around the structure calculation process. The peak restraint links save frame is perhaps more unusual. It allows the link between a peak and the restraint generated from it to be maintained. There are 2 overarching aims to our proposal for how to include relaxation data in NEF. The first is to define a NEF format for the information that is currently required when you deposit data from NMR relaxation experiments with the BMRB. And secondly, to extend this format to facilitate reproducibility of exchanging and processing relaxation data. The proposal document starts by outlining a few concepts that underlie the way we record and analyse dynamics data. I won't go into detail here, but essentially it describes the workflow of going from spectra to something like a set of relaxation rates, which can be deposited in the BMRB. A brief note about the different ways in which peaks may be grouped. This can be either within spectra, if they need to be fitted together. For this, we're suggesting the use of a cluster ID, analogous to what NMR Pipe does, or peaks can be linked across spectra, for which we are suggesting a new save frame, which I will introduce later. There are many different relaxation or dynamics experiments and data types that can be measured by NMR. R1, R2, heteronucleonoE, CPMG, CEST, etc. The BMRB has a different save frame for each type of experiment, although for many of these there isn't a single BMRB entry. For NEF, we are proposing a single save frame called the NEF relaxation list. A mandatory tag for this save frame would be the NEF relaxation list experiment type, with a predefined list of experiments. For future-proofing, we would also add the option to choose Other, with the experiment name then entered into a comment tag. Note that we are proposing to define rates and their errors rather than decay time constants, which is different to the BMRB. We felt rates were more universal across different use cases and are also more generally supported by the community. Of course, by describing any relaxation experiment with the same save frame specification, you will end up with some mandatory parameters which are only relevant to some experiments. Not all experiments require a reference spectrum, for example. But we think that doesn't really matter and is outweighed by the simplicity of having a single save frame to cover all experiments. So let's have a look at the save frames that we are proposing. First up, the NEF relaxation list save frame. Here, as an example, is an R1 relaxation list. Here is the data that applies to the whole list. Most items should be relatively straightforward. It might be worth mentioning here the relaxation atom ID. This tells us that atom 1 is the atom which relaxes. Here is the saveframe's loop, the table of values. At the top we have the column headers. And you can now see that atom 1, the one that relaxes, is the nitrogen, and the proton is the one which primarily causes the relaxation. The only other thing to point out is the data combination ID. This is relevant mainly in the context of CPMG and CEST experiments, where you may wish to group certain sites together because they have similar relaxation properties, and so you want to fit them together. Exact details on each of the tags and parameters are provided in the proposal document on GitHub. The NEF relaxation list saveframe is essentially a readout of this kind of bar chart, sequence number versus relaxation rate. But of course, each single relaxation rate derives from a decay curve, a plot of relaxation time versus peak intensity. And the whole bar chart is derived from a whole set of decay curves. In a single curve, each point derives from a peak in a separate spectrum, though of course it is the same set of spectra across all the curves. In principle, if your NEF file contains all the peak lists, you can find all the peaks that give rise to the data points on each of these curves and then give rise to each of the relaxation rates. But trying to find those peaks and match them up is not entirely straightforward and requires quite a bit of code to do. We think it is important to link these relaxation rates to the experimental data that gave rise to them. So that is why we are also proposing the non-mandatory NEF series data saveframe. This will link the peaks to the relaxation rates. One NEF series data saveframe is always linked to one NEF relaxation list saveframe, and it essentially documents what happens in these kinds of graphs. So you have a series variable, which documents the variable that you are changing across your spectra. So for R1, it is a delay time. For a CPMG experiment, it is the number of CPMG cycles. For a CEST experiment, the frequency offset. You then have a data variable, which essentially corresponds to what is on the x-axis of these graphs. So for R1, it is essentially identical to the series variable. But for a CPMG experiment, this would be a frequency. For a CEST experiment, it would be a chemical shift. And then finally, you have the data value, which is essentially what is on the y-axis of these graphs. So for R1, this is a measured intensity, but for a CPMG or CEST experiment, it would be a relative value. We propose a non-mandatory loop termed the NEF series experiment loop. It simply defines a set of NMR experiments that form a series, or it could be a set of planes from an experiment with a pseudodimension, and they are then related to a variable that changes. So here, for an R1 series, you would simply have the relaxation time that increases. You also have the option to specify a spectrum, or spectrum plane, as a reference experiment, as required for CPMG or CEST experiments, for example. You could also imagine using this loop to specify a titration series. And then there is the mandatory NEF series data loop. Note that this essentially consists of groups of rows which correspond to our individual graphs, in this case again an R1 decay curve. So here we have 3 different peaks from 3 different spectra. They each correspond to one data point on the graph, with a particular data variable, the x value corresponding here to a delay time, and a particular data value, or a y value on the graph, in this case peak intensity. They all correspond to the same relaxation rate in the same NEF relaxation list, which basically corresponds to a bar here in this bar chart. And then the next set of rows corresponds to a different decay curve and relaxation rate, etc. As I have already indicated in a number of places, we've tried to make sure we cater to CPMG and CEST type experiments in everything we have proposed. I won't say anything more here, but there are a few more comments on this in the full proposal document on GitHub. This proposal currently only includes the initial extraction of rates from experimental data. It does not include further modelled analysis, be it the extraction of order parameters, populations, or the use of detectors. Although it is by no means impossible to specify models accurately and systematically, it isn't entirely straightforward either, and we are keen to get the ball rolling on the raw relaxation data. But this certainly would be a very desirable next step. More broadly, if as a community we want to be exchanging and depositing more NMR data, we are also going to need to create NEF specifications for things like paramagnetic relaxation enhancements, chemical shift perturbations, or pseudo-contact shifts. If anyone wants to start working on these things, we'd be delighted. We would like as many people as possible who are involved in recording and analysing dynamics data or writing software to analyse such data to engage with our NEF Dynamics proposal and make suggestions for improvements. We have spoken to some people already, but we hope more will become involved now. You can post something directly on the GitHub page if you wish. You are also welcome to contact Gert and Fausta or me, Vicky Higman, directly by email, and if you wish, we can arrange to meet for a discussion on Zoom. We also plan to host some open discussion meetings on Zoom to suit a variety of different time zones. We shall also post this video on the CCPN forum, and you can leave feedback in that thread. The link to this is available below. We shall aim to make feedback available to others, anonymously if desired, either via a feedback document on the NEF Github page or on the CCPN forum thread. We are keen to emphasise that although CCPN has put forward this proposal, and we have a strong interest in using and encouraging others to use the NMR Exchange format, this is not a CCPN thing. NEF belongs to the community, and we want and need everyone's participation in moving this forward. The NEF GitHub page has more information about the NEF Consortium, including a copy of the Charter. Thanks for watching this video, and do be in touch if you have any comments or questions.